Hello everyone. Today for this cantilever beam we are going to draw shear force and bending moment diagrams. In this beam there is uniformly varying load. It varies from 0 in the free end to 72 kN per meter at D, which is at a distance of 3 meter from the free end. Then we have uniformly distributed load 12 kN per meter. It acts for a distance of 4 meter from the free end. The uniformly distributed load is acting upwards. By using this rule, we can find RA. RA is acting upwards, so it will be positive. The UDL is acting upwards, so it is also positive. We have to multiply the magnitude of UDL with the distance, which is 4. The UVL is acting downwards, so it will be negative. For the UVL, we have to take the area. Let us take this triangle. We know the area formula of a triangle, half into BH. Here the breadth is 3 and the height is 72. So this is the area. For RA, we will get 60 kN. To find MA from the point A, let us take moment about B. In this case, we have to follow right hand side rule. MA is acting in the anti-clockwise direction, so it will be negative. RA is acting in the clockwise direction, so it will be positive, and the distance is 2 plus 1 plus 3, so it will be 6. The UDL is acting in the clockwise direction, so it will be positive. We know that with the UDL we have to multiply the distance and then the distance upon 2. The UVL is acting in the anti-clockwise direction, so it will be negative. For the UVL we have to multiply the area with the centroid distance. We know that this is the area of the triangle. The centroid distance about B is 2 upon 3 into breadth. Here the breadth is 3, so it is 2 upon 3 into 3. For MA, we will get 240 kN meter. Using the right hand side rule, we can find the shear force values at A, C and at D. Shear force at just left of A will be 0. Shear force at just right of A will be RA, which is acting upwards, so it will be positive. Let us find the shear force at C. Up to C, there is nothing except RA, so shear force at C also will be the same 60 kN. Let us find the shear force at D. RA is acting upwards, so it will be positive. The UDL is also acting upwards, so it is also positive. With the UDL, we have to multiply the distance. For the shear force at D, we will get 72 kN. Using the left hand side rule, we can find the shear force at B, which is 0. Here you can see the shear force diagram. In this point, the shear force becomes 0 and change the sign. So in this portion, the shear force will be negative. In this point, the shear force becomes 0. In this point, there will be maximum positive bending moment. In that point, let us make a section at a distance of x from the free end. Using the left hand side rule, let us find the shear force in that section, which is 0. The UDL is acting upwards, so it will be negative. We know that with the UDL, we have to multiply the distance. The UVL is acting downwards, so it will be positive. For the UVL, we have to take the area. We need to find the area of this triangle. First, we need to find this height. For the distance of 3 meter, the height is 72. So for 3, it is 72. But we need the height at the distance of x. So we have to multiply with the x. So this height is 24x. Now we can find the area. We know the area formula, half into BH. Here the breadth is x and the height is 24x. In this way, for x, we will get 1 meter. Using the right hand side rule, we can find the moment values at A, C and D. Moment at just left of A will be 0 and at just right of A will be MA, which is acting in the anti-clockwise direction, so it will be negative. Let us find the moment at C. MA is acting in the anti-clockwise direction, so it will be negative. RA is acting in the clockwise direction, so it will be positive, and the distance is 2. For the moment at C, we will get minus 120 kN meter. Let us find the moment at D. MA is acting in the anti-clockwise direction, so it will be negative. RA is acting in the clockwise direction, so it will be positive, and the distance is 3. The UDL is acting in the clockwise direction, so it is also positive. We know that with the UDL we have to multiply the distance and then distance upon 2. In this way, for the moment we will get minus 54 kilonewton meter. We know that in the free end B, the moment will be 0. Now let us find the maximum positive bending moment. We have calculated it occurs at a distance of 1 meter from the free end. This height will be 24x. 24 into 1, it will be 24. Using the left hand side rule, let us find the maximum positive bending moment. The UDL is acting in the anti-clockwise direction, so it will be positive, and the distance is 1. We know that with the UDL we have to multiply the distance and then the distance upon 2. The UVL is acting in the clockwise direction, so it will be negative. We have to multiply the area of this triangle with the centroid distance. This is the area of the triangle. The centroid distance about the height is 1 upon 3 into breadth. Here the breadth is 1, so it is 1 upon 3 into 1. In this way, for the maximum positive BM, we will get 2 kilonewton meter. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. It changes the sign from negative to positive. This point is called point of contraflexure. In the beam, we can make a section and find this distance. You can see that here I have made a section at a distance of x from the point B. Using the left hand side rule, let us find the moment, which is 0. The UDL is acting in the anti-clockwise direction, so it will be positive, and the distance is x, so x into x upon 2. The UVL is acting in the clockwise direction, so it will be negative. This is the area of the triangle, and this is the centroid distance. For x, we will get 1.5 meter. For this particular loading only, we have got the negative as well as positive bending moment. But with a different loading, it may change. Now we are going to end this session. Thank you for watching this video.